Hey guys, welcome to this video. Today we will talk about retrieval augmented generation and more specifically how to use it to do question answering. And what you see on the screen is a blog post from Cohere, which is basically the motivation for this video. And the main premise of this article is that a lot of companies, a lot of people have OpenSearch/Elasticsearch database already, and they had it before this semantic search vector database hype, right? And they would like to do some clever searching. However, they don't want to migrate all the way to, let's say, full-blown vector databases. And what this blog post suggests is a, let's say, Cohere solution, which is called reranking, as you can see here. But let me now move to a sketch that I prepared. Let me show you or describe how standard semantic search and retrieval augmented generation works. So we start with the question, right? And then we have some kind of an embedding model. And this embedding model turns this question into a vector of numbers, an embedding. And then it sends this vector into some vector database. Note that OpenSearch and Elasticsearch actually support k-nearest neighbors searching or approximate KNN. I mean, nowadays there are so many of them, right? Things like pinecone and so on and so on. But yeah, the idea is that for each document in your DB, you need to have a corresponding embedding. And as you would imagine, if you have billions of documents, this might be super tricky, right, to generate. And probably wouldn't be the best idea to just take a random endpoint online and run it 1 billion times and hope it's not going to be too expensive. Anyway, once we assume we have this database, we basically take the question embedding or the query embedding, we compare it to the database embeddings, and we find the two, let's say, most similar documents, right? The orange one and the purple one. And what we do after this is that we take the question again, we take the retrieve document, and we send it to some kind of a chat completion model, something like ChatGPT, right? And we kind of hope that we can force it to read these two documents for us and kind of decide whether they contain the answer to our question, right? And why do we do retrieval augmented generation? Well, these models nowadays, right, they are always trained on some fixed data set that was collected at some moment in the past and cannot know about recent events, right? Or if you have some custom documents, right, for you that are specific to your company, there's no way the chatbot on its own is going to know how to answer this question. So that is why it's kind of necessary to provide some documents. Anyway, so this is the nowadays pretty standard way of doing things. What the Cohere blog post suggests is to actually completely get rid of the embeddings. And the idea is that we again start with the question and then we directly send it over to OpenSearch. And what it will do, it will use a default searching algorithm, which is BN25. And the problem with this algorithm is that it's not semantic. So it's not going to capture things like synonyms. However, even though this BM25 search isn't perfect, it is still good enough, right? And the huge benefit of it is that you get it out of the box by just using Elasticsearch and OpenSearch, right? You don't have to pay any extra money to some external embedding API and so on and so on. It just is a part of the database. What we do then, we take these, let's say, documents and we send them to a reranking endpoint or model, right? And we're hoping that this reranker will look at the question, look at the retrieved documents, and it will kind of reorder them based on relevance, right? Because again, the BM25 searching will be imperfect. And then we are in the same situation as before. We have two documents that we send over to a chat endpoint together with the question. And yeah, we're hoping that the large language model will just read the documents, read the question, and then decide whether the answer is findable inside of the context. Cool, so that's the idea. I suggest we just move to some code, like minimal example that basically implements this pipeline. And yeah, I might have some other comments along the way. All right, so let's start by getting our OpenSearch database. I'll just copy paste this Docker run and add one line to it. So basically what this does, we will create a single node database, and also we want to switch off security completely. Let me check what the environment variable is. Yeah, it should be disable security plugin, and this one is equal to true. So let's run this. And we detached, but if I do docker ps now, everything should be running. There should be 2 ports that are exposed and forwarded. We care about this one primarily. And now that we have our DB, let me actually move to Postman. So we will be using basically 2 APIs. One is the one from OpenSearch. By the way, this is one of the reasons why I love OpenSearch. It's a database that you can completely control via RESTful API. So it is really transparent and easy to use. And then we will be using Cohere's endpoint. Anyway, when it comes to OpenSearch, let's just try some requests. So first of all, we have this get all indices request, right? Here I just have a variable, it's localhost 9200, and let's just look at all the indexes that we have in our database, and as you can see, there's just one, some default one. So I suggest we go to another endpoint, right, where we directly create an index. And there's nothing interesting here. We just make sure that we specify the settings. We have a single shard and a single replica, and the mapping basically defines the schema. And our schema is super simple because we will have a single field called stuff, and the type of this field is text, right? If we set type of the field equal to text, we basically allow like textual analysis on this field, which means that we can run BM25 by default. So let me do this. Seems like it went through. Let's go back to the get all indices, and now we have our cool index inside. So we have more, let's say, requests here. Is this one correct? I think I messed this one up. Yeah, this is basically how one can remove an index. Let's give it a try actually. If I do this. Yeah, so now there is no index anymore. Long story short, you can basically do everything through this RESTful API, but later we will actually use a Python client that under the hood calls this REST API. Let me recreate that index. And yeah, what are some other important endpoints? Yeah, adding a document is as simple as sending a post request to this endpoint, right? Where you basically say, hey, this is the content, so let's just send one. This is just some document. Hello, this will be a second one. And finally here we can list by using this post request all the documents we have. Right now we should have just 2 of them, right? 1, this is some document, and 2, this is some document, hello. Cool. And as you can see, Elastic or OpenSearch creates identifiers for us, which is super useful. But yeah, so here we searched for every single document because we set match all. However, what we will be doing in our retrieval augmented generation, right, is the following. It will be again a post request to this search endpoint. However, now we just say, hey, look at the field stuff and try to match this query text, right? What's super interesting, we will also get scores, right? So the higher the score, the BM25 score, the more relevant the document is. So yeah, that's the quick overview of the OpenSearch endpoints. And let me also talk about the Cohere endpoint. So Cohere has a bunch of endpoints, also companies like OpenAI. The embedding endpoint is actually something we are not going to be using, but not surprisingly, basically for every input text, right, you get a an embedding, they have like a 4096 dimensional one. Again, we're not going to use this one. What we are going to use are the two following endpoints, right? There's this rerank endpoint, and by the way, I will share the Postman collection on GitHub so that you can try it yourself. But anyway, the rerank endpoint, what does it do? It accepts a bunch of documents. Here, I think we have 4, right? And it also accepts a query, right? And yeah, it does exactly what the name is. It tries to order the documents based on the relevance with respect to that query, right? So it's like here, it's saying, hey, I think that the document number 2, which is 012, is the most relevant one. And it also provides the relevance score, right? So in theory, what we can do, right, like as you saw, we will get a bunch of documents from OpenSearch, but then we will send them through this endpoint, and let's say only take the 2 most relevant ones. Cool. And finally, let's move to the chat endpoint. This is, yeah, I think I messed up. Let me fix it. You can actually find it in their documentation. I think it's pretty nice. You can go to API reference and here you choose which one you're interested in. Let me copy paste this one to Postman. It's always the same logic. And by the way, I have generated my API key that is always pasted under the hood. Otherwise it wouldn't work. Let me put this one in here. So yeah, it's very similar to the OpenAI endpoint, right? You have some kind of a chat history where you basically have interleaving roles, user chatbot. And now, by the way, we don't want to use these connectors. They are related to retrieval augmented generation, but let's not talk about it now. And is it chat? Yeah, let's see. And as you can see, it replied. So these are the endpoints. I am going to save it, and as I said, I will share it. And basically just using these endpoints, but we will build our example. And again, let me stress that we are not going to be using, let's say, HTTPX or requests to send the raw requests. And instead, we are going to be using the client libraries of OpenSearch, or the Python client or SDKs for OpenSearch and Cohere. So first of all, I suggest we just create a dummy input txt where we will dump all the documents that our database will contain, right? So input txt, and let me just copy paste this. I prepared this in advance so that I kind of illustrate, let's say, the power of the reranking. So basically there are 2 categories, right? One is about like age of people and favorite food of different people, and then we have some sporting events, and then I also noted the questions we want to ask. But our first goal, right, is to, let's say, go line by line in this document, ignore the comments, and just somehow call the, let me go back to Postman, call the add document endpoint, but using the Python SDK. So let's go for this. Let's call this upload data .py and do some imports. Yeah, so I believe I will need to install this. So upload data, yeah, sure. So pip install OpenSearch py. And I think there might be a dash here. Yeah, cool. So we have it. Let's write some parameters here. I'm not going to make this any fancy or sophisticated, super simple. So we have our data in input txt, right, on the left, and index name will be cool index, because we will do the index creation inside of Postman, right? You can also do it with the client, but I thought we might speed things up by doing it in Postman. OpenSearch, right? And here we just want to provide where our host is. There can be multiple hosts, and as you guys saw, Docker PS, this is basically localhost 9200, right? So I just say localhost, and here we provide the port, which is 9200. Cool. And now in theory, if I do client ping, things should work. Let me try. Yeah, and let me maybe print this. Because the ping basically guarantees that if it returns true, it guarantees that we did everything correctly. Cool. So this is how we connect to our DB, right? And let me go back to Postman and let's just make sure that we first, let's say, delete the cool index here, and we create it from scratch so that it's empty. And if you look at all the indexes, yeah, we have it here with 0 documents. Amazing. Don't save here. Let's write the code. So as I said, we want to literally just iterate line by line through our input text on the left, right, and put every single line in our DB. So with path input file open sf, and here we'll just be counting how many lines we added. And not if it's an empty line, right? Or if the line starts with a comment, let's just continue, right? We just want to be able to have some comments on empty line. And if it's not the case, let's print this. We are adding document number I. And finally, this is the SDK's way of adding a document. We provide the index name we want to add the document to, and then we provide a body stuff and line. And let me remind you that stuff was our field name. Let's actually put it here so that it's clear. Field name is stuff, and find stuff field name. This looks great in my opinion. So if we try to run this, so let me go back to Postman, right? So as you can see, as of right now, our index has 0 documents. However, after running this, yeah, I forgot to increment the I. So now already it should be different. Let's see, list all documents. So here, maybe I should have refreshed. But yeah, as you can see here, we have 11 documents, and get all indices. Yeah, took some time, but we have 11 of them. So we are done with writing our data, right? So let me close this file on the left. Let's actually now go and try to implement the question answering logic. So let's write a script called answer. Cool. And this answer is going to have a bunch of imports, as is always the case. First of all, we import this Cohere Python client, right? I need to install it. But then again, OpenSearch by import OpenSearch. So but this one, by the way, I can kind of get from the other file we just wrote, right? So I can definitely just put it here. And let's call it OS client. And pip install Cohere. And also let's have a bunch of parameters here. Parameters at the top of the file. So we have again the index name, which is going to be cool index. Field name, which is going to be stuff. retriever k is going to be 5. So what is retriever k? Let me go back to my diagram. Retriever k is going to be the number of documents after doing BM25. So here the retriever k would be 3. However, in theory, it can be anything we want, right? And then we will have Reranker k, and let's put this to something lower. And as you would imagine, Reranker k is actually, in this case, 2. So the Reranker will take all of the 3 documents and it will sort them, and then it will spit out, let's say, the 2 most relevant. I mean, there's no speed up if we just take, let's say, something smaller here, but what's important eventually is that we don't send too many documents to the chat endpoint, right? Because chances are that we are being built based on the number of tokens. So in a way, one of the goals is to make this as short as possible, or to have as few documents as possible, while making sure that those documents actually contain the answer. So we have the Reranker k and Cohere API key. That's something I will read from the environment. As I mentioned, you guys need to get this from their website. Cohere API key. Cool. And finally, the question that I will actually put here, right? Instantiate clients is going to be passed through the command line. So the first argument, argv1. So just to make sure that everything works, print question. So if I do Python answer, this is the question. This will take some time, but yeah, everything seems to be working, so we can remove it for now. However, let us like write the retriever logic right now. So we have instantiated our OS client, and as before, we will use it to kind of send requests to the database. Let's basically run BM25 search. Let's make sure it's correctly set up. So the way you do this, you use the search endpoint, right, as we saw in Postman. You provide a parameter called body. And this parameter will need to look like this. It's a nested, let's say, JSON or dictionary. It's a little bit confusing, but you just need to say, hey, match. And here we want to specify the field name, which will be stuff, right? And here it should be the actual question. So this is what we need to provide to OpenSearch, right? And if I'm not mistaken, let's actually see what we get, right? So if I do Python, I'm here. So OS results, as you can see, there's a bunch of stuff. So it contains a lot of metadata, but what we want is to go inside of the hits, then go inside of the hits again, and then it's a list, and then each of the elements has this source key. So let me write the comprehension maybe here. So let's do source for x in, and inside of the source we actually want to go for field name, something like this, in OS results hits. This is a little bit ugly, but it is what it is. It's never close, sure. So as you can see now, this will basically give us all those all those things we retrieved. And if I'm not mistaken, we should be able to just say size at one point as well. Let me actually do this because we want to use our retriever k parameter. So let me copy paste this one. So let's call this contexts. So here we just say size and it will be our retriever k. Yeah, I hope it makes sense. So if we say retriever k, in our case it was 2, if I'm not 5, if I'm not mistaken. This should be 5 or lower, right? If there are no relevant things. But if we were to, let's say, put it to equal to 3, contexts, as you can see, there are 3 things. Cool. So anyway, let's just go back to 5 here. And so we have successfully implemented this retrieval part, right? We give it a question and our retriever, our OpenSearch, spits out on the relevant documents. Now we would like to send it over to the rerank endpoint, right? These contexts that we have. And again, it's super easy with the SDKs. So first of all, let's just print it out. So OpenSearch gives us contexts, right? Cool. So here, let's create a Cohere client. So Cohere client is going to be Cohere client Cohere API key retrieve. Now we want to do rerank, right? And this one should be super straightforward. We do Cohere results equal to Cohere client rerank, and we provide the model, which is something we need to provide. So rerank English. I think they have more. Feel free to read about it in the docs, but yeah, the query is going to be our question. And then we have the docs parameter, which is our contexts. And finally, top n, which shows how many top documents we want to return. And yeah, that should be it. And let me print it nicely, maybe. Let's see. Again, it's some nested, let's say, object. So let's maybe get there. Docs, rerank. It's not docs, it's documents. Yeah, so how does this thing look like? Cohere results. So as you can see, it's some kind of a special class, rerank result, but it actually should contain more things. So for example, here it has things like the relevant score, which is super interesting, right? And the original text itself. But I suggest we literally just extract the text. So let's do this. Rerank contexts is equal to our document. So we take this object and just get the document, and then it's inside of the text. Because yeah, if I'm not mistaken, document, and then it's inside of the text. Yeah, so that's what we need to do for R in Cohere results. And yeah, let's do Cohere ranked and re-ranked contexts. I think this looks good. Let's continue. And yeah, as you can see, we have 5 retrieved documents from Elasticsearch. Then we have 3 of them that are, or just 2 of them that are returned from the Reranker, because we had Reranker k equal to 2. That's amazing. So the only thing left here, right, we are here, is to write a prompt that is going to combine these documents with the question, and then this prompt will be sent over to some large language model, next token predictor. And to do this, let me write a helper function, right? So chat completion. And this helper function, I will probably just copy it so that we don't spend too much time on things. Yeah, this is how it looks like. So one provides the question, right? And the rerank contexts. And what it will do, it will write the following. By the way, this is inspired by LangChain. And also, by the way, all of this can be done via LangChain and similar, let's say, tools pretty quickly. But I guess the point of this video is to show you how things work under the hood. So anyway, given the following extracted parts of a long document and a question, create a final answer with the references. So not only we want the model to give us the answer, but also tell us, hey, I used document 5 and document 2. If you don't know the answer, just say that you don't know, don't try to make up an answer. Always return sources in part in your, the sources part in your answer. Cool. And what do we do next, right? We first of all add the question, and then we join all the contexts, and finally we kind of prompt the model to start writing the answer. I will show you how this looks like. So I will maybe put this helper function at the top, right? Helper, and what do we do? Yeah, chat completion is that we say prompt is going to be equal to create, or what was it, generate prompt, and was it the question that goes first? Yeah, question and context. So question and re-ranked contexts. So let's see how it actually looks like, our prompt, before we send it anywhere. So this is our prompt. It looks exactly like we wanted, right? So we ask a question. This is the question, it's a little bit confusing. And these are the 2 re-ranked documents that we are sending over. All right, so now, not surprisingly, the only thing left is to just send it to another Cohere endpoint. And again, here you can be using any other endpoint. So response is Cohere client chat. Chat history. So for now, since it's like a one-off conversation, it's not like a chat, it's literally question answer. We just say there's no chat history. And we say that our message is the prompt. That's it. And finally, we print the answer, which should be response text. And let's see whether it works. So let's do something better here. What is the like today? And as you can see, the model said, hey, the answer is, I don't know. The sources did not provide any reference to the weather, which is correct, because if I go back to our original input, right, I did not talk about the weather at all. But anyway, let me remove this input prompt, and I think we are ready to go. And let me show you why the re-ranking might be a good idea, right? I custom made these documents and these questions so that it's clear, but yeah, hopefully you'll find it helpful. All right, so this first part of our documents is about some people, right, and their ages and what food they like. So for example, Adam is older than Ben, right? Let me maybe zoom in here. Right, Ben is older than Charles, and then what their favorite foods are. But let's use this question, right? So if I use what is the favorite food of Charles, let's see what we get. Answer, change till this one. And let's try to digest what we see here. So using the retriever from OpenSearch, the most relevant result is Ben's favorite food is an apple. However, note that we are talking about Charles, right? The second most relevant thing is Ben is older than Charles. And then the third one is about Adam eating carrots. So as you would imagine, if you were to cut it off already here after the 2 documents and directly send that to the large language model, it would not know I'm kind of thinking about the answer. It's funny because there is no random state, or is there? Yeah, okay, here this one is a little bit better. But anyway, my point is that if it wasn't for the reranking, which did an amazing job, cutting off the raw Elasticsearch or OpenSearch results would lead to irrelevant context, right? So definitely useful. And why is this happening? So the way I designed this example is the following, right? I made sure that the question itself contains words that are inside of other documents. So for example, food, right? Or favorite food, as you can see, there are two words in this question that correspond to this question. So in a purely lexical search, right, we just literally count up the number of occurrences of words, more or less. We do some weighing. Yeah, feel free to look into BM25 and let's say TF-IDF. However, here we are more interested in the semantics, right? So what's important is that Charles, like we talk about Charles, and that something he likes or loves, right? So in a way, love a food is the same thing as that food being your favorite food, right? So this is something that the BM25 search cannot understand, right? Let me give you another example, another handmade example. So the second part of our documents is about like some countries and what championship, what World Cup they won. And some sports they're good at, right? And here the question goes like this. What country managed to become world football champion after 2050? Right, it's something in the future, right? This is something completely kind of untrue. These are not facts, but that's the point of retrieval augmented generation. You want the model to use your documents to answer your question. So let's try what happens if I ask this question. And yeah, as you can see, again, this is the same scenario. If you were to only look at the retrieval, it again thinks that like some irrelevant contexts are actually relevant, right? And it's only, let's say, the third context that contains the answer to the question. And the Reranker, again, correctly understood this. And the trick, again, is the same. You want to use synonyms, right? So world football champion, well, FIFA, if you're not familiar, it's basically the organization that's in charge of football championships, right? So the model doesn't have this knowledge, or let's say the retrieval doesn't have this knowledge that football and FIFA are semantically super similar. And that's why it was suggesting, let's say, Mexico first, because here we have like world champion and Mexico. Actually, I think it's the 2050 that kind of made OpenSearch believe that this is the most relevant one. But here we said after, right? So to kind of answer this correctly, you need to have some semantic understanding of what's going on, and this is what the Reranker provides. But let me also give you one example where the retrieval fails completely, right? And this kind of shows that, okay, this Reranker trick is definitely nice and it's low effort, as you can see. However, maybe switching completely to embeddings and abandoning BM25 might be the right choice for you. Let's try. Who prefers vegetable the most? So what's tricky here, right, is that the word vegetable is not present in any of the contexts, and also prefers is not present in any of the contexts, right? We have things like favorite food, we have things like love, also we have words like carrots. So to answer this question, if I'm looking at this, the answer would be Adam, right? Because his favorite food is carrots. carrots are vegetables. So that's what we were expecting. However, let's see what happens. So as you can see, it's OpenSearch completely misunderstood, and it used the other documents. And why? Well, there would be probably some overlap, right? Yeah, I think it's the article that kind of swayed OpenSearch into believing that there are similarities between our question and what it returned. So yeah, this is just an example that shows that this approach is not perfect, so be careful about it. However, in my opinion, it's super simple. This was a minimal example, right? But what's important about these technologies is that you can scale them up. For example, OpenSearch, you can have it locally. You can have a single node, single Docker container deployment. You can have on-premises deployments. You can have AWS deployments. Anyway, I think that's all I wanted to talk about today, and I hope you enjoyed it, and I will see you next time.